Rancid fats are things that we could talk about and do a whole seminar on because there's so much information and so important for a lot of health conditions. So rancid fats primarily occur with unsaturated fatty acids. So in other words, saturated oils are more stable to oxygen, heat and light. The unsaturated are more susceptible to rancidity because of the structure with many double bonds. So the more double bonds, the easier it is to become oxidized for oxygen to attach to one of those double bonds. Fats turn rancid in the presence of free radicals, in other words, reactive oxygen species, which we talked about last module. Here we've got an unsaturated double bond there, unsaturated lipid there. Here we've got a hydroxyl radical, an OH with a free radical on there, an extra electron on there, which then donates its extra electron to the oil here, where the H position is. The H then goes off with the oxygen to make water. This is what's called a lipid radical. So at this stage, the fatty acid has become a radical. Okay, this then in the presence of oxygen here gets a double oxygen with a radical. So this is a lipid peroxyl radical, which then goes with the ordinary acid again, unsaturated oil, and becomes a lipid peroxide. So we get two oxygens and an H there. So we've got three rancid types of fats. So we've got lipid radical with one free radical, and then we've got a peroxyl radical with two oxygens, and then we've got the peroxide here with the hydrogen there. And this then degrades to a compound called malonaldehyde. And malonaldehyde is the markers we'll see for rancid fats. Now malonaldehyde, I tend to find, tends to be high with people when they're taking rancid fats in from outside. Okay? Now, the body does produce malonaldehyde, and it is a sign of oxidation. But in the majority of people who weaken to malonaldehyde, the big problem is the oils that they take in. It's mostly the oils that they are actually ingesting from a culinary point of view, from a cooking, what they put on salads, what they put on their bread, etc. These are the big problems with people with malonaldehyde. You need to look and go through all the oils that people do. And the worst, as we'll find, of all of them, and the most common, is olive oil. Olive oil, in the vast majority of cases, is rancid before you even get it, open the bottle up, because it's too old by the time it gets into the shop. In most cases, it's anything up to 2 years or even older by the time you buy it. So it's gone rancid long before you actually start to use it. So reactive oxygen species, or free radicals, as we talked about last time, degrade polyunsaturated oils, forming malonaldehyde. So malonaldehyde is one of the two markers for lipid peroxidation that we can use. Reactive aldehyde from the malonaldehyde causes toxic stress in cells and forms advanced lipid oxidation end products. This leads to a loss of membrane integrity, so the oxidized oils start to react strangely in comparison to normal oils as far as their chemical properties. Malonaldehyde is used as a biomarker to assess the degree of oxidative stress of a person. So this is within their lipids. So it's not going to tell you about other free radical reactions which don't affect the lipids, but it will tell you about lipid oxidation. It reacts with deoxyadenosine and deoxyguanosine in DNA to form DNA combinations which can become mutagenic. So in other words, build-up of malonaldehyde is quite serious, okay, and it's a very, very common problem with a lot of health conditions. So it causes a degradation of our DNA structures. It's a colorless liquid. It's a highly reactive compound that occurs as an enol. It occurs naturally and is a marker, we've said that as Mark's data set. It's reactive and potentially mutagenic, so it can spark off cancers. In other words, it's carcinogenic because it's a compound where we've got lipid oxidation. It has been found in heated edible oils, such as sunflower and palm oils. It can also be found in tissue sections of joints from patients with osteoarthritis. So you can get any form of degeneration if you've got a build-up of lipid peroxides, rancid oils in your body, because every cell membrane in your body, not just the cell membrane around, but all the internal membranes around the mitochondria and the nucleus, are all made of these phospholipid structures. Oils should be, and this is important for all oils should be organic. Okay, now what does that mean? Does it mean that they're sprayed with pesticides and herbicides? Yes, in a lot of cases. But in some cases they don't spray. You know, nobody really sprays walnut trees, for instance. And most of the time they don't spray olive trees because they're everywhere. But they do put pesticides on to stop that insect. What's that insect called?
The olive blight.
The olive blight, isn't it? Yeah.
This year, it was really hard.
Yeah. So that's a pain. So a lot of people do use pesticides, or there are natural ways of dealing with it with special little cages there. But it's mainly the extraction process. So the extraction process in a lot of seed oils involves using solvents. And the main solvent that is used is hexane, which is a well-known solvent, to dissolve the oil out of the mush. By the time they ground the seeds down, you want to then take the oil part out, so you need a solvent, and then they evaporate the solvent off. But nonetheless, there may be residues left of the solvent. So organic means not just, you know, no pesticides, no sprays, but it's in the processing as well. It should be in small bottles. The bigger the bottle, the greater the oxidation, because you're going to open it up every time and you get more air in it, it's going to get older. So you may start off with a beautiful oil, but by the time you got to the bottom of that bottle, if it's a big bottle, so small bottles, and it should be dark glass bottles, which is why we put ours into Miron bottles. Have you got a Miron bottle over there? This is a good example of a dark bottle which has no light, visible light, thank you, that comes through that. So it protects it from at least the effects of light. It should be kept away from heat, so don't keep it on your Aga or your Rayburn or by the cooker too close. Some oils do tend to go solid if they're kept in the fridge, so somewhere cooler, not necessarily in the fridge, but somewhere cooler. What you've got to remember in the fridge is, if you lay them down, is to make sure you put the top on properly. Otherwise they do leak out a little bit. And of course, you get a little bit of oil on the thread there, so don't fly with them. You know, if you opened a bottle up, leave it on holiday or whatever, because if you try to come back with a bottle that you've opened and it's got a bit of oil on the thread, which it'll unscrew with the change of pressure, and then you'll have a mess in your suitcase. So small bottles, dark bottles, keep away from heat, and keep the top on, okay, because that's where the air or the oxygen gets in, okay? So if you leave the top off, you're going to have greater exposure to oxygen. Some people suggest you put a drop of water on there after each time. Just one drop is enough to spread across the top there, and it seals it from the oxygen, and the oil will last a lot longer. When we manufacture, and most companies, when they manufacture, put nitrogen on. We float nitrogen on, so there's no oxygen in there, and that stops it from going rancid. When we receive our bulk oils, they're all in nitrogen, and then we put nitrogen, we pump nitrogen onto the top, and then you don't get oxidation to begin with. So the important thing is organic, cold pressed, which we'll talk about, which means that when they extract it, it's less than 100 degrees centigrade. So if it's in a commercial press, and the friction of the press may increase and take the temperature of the extraction process above 100, in which case the oil is going to twist and turn into a trans fat. Keep the tops on and keep away from heat. And I will almost guarantee you, if you test any of these oils, they weaken. Almost guarantee it, before you've even started to cook or put them on your salads. So if they are rancid and you're just taking rancid oils in, again, that same thing, the body doesn't know with it whether that double bond is twisted or oxidized. It will take it up. So the more rancid oils you take up, the more rancid you become. It's as simple as that, really. In other words, you're aging your process even more. So the more cooked oils, cooked fats, deep fat fried, the more you're going to become like that. So rancid oils is a measurement of the stability of the oil. The Rancimat is a standard laboratory test method which measures the progress of oxidation of an oil. It measures the volatile oxidation byproducts, which are largely single carboxylic acids, the main one being formic acid. So formic acid is the byproduct of rancid oils. So remember we talked about rancid oils, formic acid creating the itching with people. So formic acid therefore is a biomarker for rancid oils. Formic acid is also produced by the breakdown of methanol and of formaldehyde in fermentation processes, but it's a single carbon 1 saturated fatty acid. Now hydroxynonenal is another marker. It's an unsaturated hydroxyl alkyl that is produced by lipid peroxidation in cells. It has 3 reactive groups, an aldehyde and a double bond and a hydroxyl group. It's found throughout all tissues and in higher quantities during oxidative stress due to increases in lipid peroxidation chain reactions. It has been hypothesized to play a role in cell signal transduction in a variety of pathways from cell cycling adhesions. It's generated in the oxidation of lipids containing polyunsaturated omega-6 oils. So one of the differences between malonaldehyde and 4-hydroxynonenal is 4-hydroxynonenal seems to be predominantly omega-6 oils. And in my clinical experience, when a person wakens to hydroxynonenal, it tends to indicate that the oil is rancid inside the body. So with malonaldehyde, it's more from outside oils, although this is strictly not in the text, but clinically, whereas peroxynitrite is an indication you're going rancid in your body, which means you've got a high degree, generally a high degree of oxidative reaction going on inside you. Okay? So you're going rancid inside with malonaldehyde, malonaldehyde, it's more from outside coming in. Right? But that's just my clinical observations. I don't think the books are going to actually substantiate that, but that tends to be what we find. So what protects an oil from going rancid is very simple. It's the vitamin E content. Vitamin E is the protector of oils going rancid. So every oil, vegetable unsaturated oil, plant oil, contains a percentage of vitamin E in varying amounts. So some oils have a higher amount of E than other oils. If the amount of E in the oil is low, it'll go rancid quicker. So when the vitamin E is used up, in other words, the oil is exposed to heat, light and oxygen, it uses up the vitamin E. And when the vitamin E gets to 0, then the oil goes rancid. All the time there's vitamin E in there, it won't go rancid. So it's a good idea from what we do is we add extra vitamin E into the oil before it's gone rancid to protect it, for it gives it a longer shelf life. On the other hand, if an oil's gone rancid, you can't reverse it by putting vitamin E in it. You can't de-rancify an oil once it's gone. Okay, so, but you can protect an oil for a longer period of time. And this is why some oils are much more vulnerable. Something like DHA or EPA, which have got 5 double bonds, can go rancid very quickly in the presence of oxygen, which is why you shouldn't really use them as oils, because they've probably already gone rancid before you actually take them. This is why they encapsulate them. So for fish oil, DHA, we suggest you always use capsules. Flaxseed is another one. The shelf life of flaxseed as flaxseed oil, once you open a bottle of flaxseed, is little more than 2 weeks. And it's gone off. You can taste it. It leaves that bitter taste in the mouth. So always use capsules if you're going to take oil for a long time. If you're going to use an oil, if you happen to use a flaxseed oil, then use the oil very quickly. Don't go and buy a litre of it, because it just won't last. By the time you've got a few weeks through it, it's gone rancid. And then you're actually ingesting rancid oils, which wouldn't be a good idea. So think of hydroxynonenal generally as a rancicity inside. And both malonaldehyde, high levels, and nonenal are really indications that you've got a vitamin E problem. So probably the nutrient of choice that will come up in your testing will be vitamin E. So think about it that way. Is it the oil that's the problem? Yes, if it's rancid to begin with. But if you're going rancid inside, it's because you've got a low level of vitamin E. So you need to supplement with extra vitamin E. So hydroxynonenal, as we said, is generated in the oxidation of lipids containing polyunsaturated oils, mainly in the omega-6 oils. These compounds can be produced in cells and tissues and living organisms, or in foods during the processing and the storage. So nonenal could be made in foods which have gone rancid, although that's more likely clinically to be the malonaldehyde. But if they are in the process, the same as malonaldehyde really, then they can be incorporated and absorbed from the foods in the diet. Since 1991, they are receiving a great deal of attention because they are being considered as possible causal agents in numerous diseases. So we could count that as both nonenal and malonaldehyde, such as chronic inflammation, neurodegenerative diseases, adult respiratory distress syndromes, atherogenesis, diabetes, and different types of cancers. So there's lots of things that can cause that mixture of different disorders. But if we put this into the melting pot along with, say, GGT and rancid fats, you can begin to say, well, you've got a bit of this and a bit of that, and so multi causes of a lot of these conditions rather than just one individual one. A small group of enzymes are specifically suited to detoxify and remove hydroxynonenal, and that would be the same with malonaldehyde because they're the same thing. Within this group are glutathione S transferase. So this is the enzyme that introduces the toxin to glutathione to conjugate with to detoxify. So glutathione S transferase is an enzyme which we call the matchmaker. So it says to the toxic metal, it attaches to the toxic metal and takes the toxic metal to the glutathione to then conjugate and get rid of. Okay, so there's considered to be about a 40% percentage of polymorphisms in glutathione S transferase. So 40% of the population have problems in this detoxification. So when we look at the ability to detoxify and the principle of glutathione as the major intracellular detoxifier, we can see that not only can we not detoxify hydroxynonenal and malonaldehyde, but we actually get a build-up then of adjuncts to the DNA, so we're getting up damage to our DNA tissue within our nucleuses. Aldose reductase and specific aldehyde dehydrogenase enzymes also detoxify, but I think the principal one here is our old friend glutathione. So vitamin E, this is the major protection to oils from going rancid. Vitamin E is actually incorporated into cell membranes. So here we see vitamin E within the cell membrane itself. And along comes a reactive oxygen species or free radical. And as we see, the vitamin E itself becomes a free radical then. So the vitamin E becomes a radical, and then it has to be recycled back. So one of the best sources of oil, of E, generally is wheat germ oil. Okay? This is going back to the times of Weston Price and Royal Lee many, many years ago, and Dr. Goodhart, who took a lot of his works from Royal Lee, found that the best source naturally of vitamin E was wheat germ oil. So it's one of the highest, if not, it's actually the highest source of E in any plant oil source. So it's a rich source of tocopherols because vitamin E contains 4 tocopherols and 4 tocotrienols. Combination of enzymes, catalysts, plant compounds and minerals. So it's not just vitamin E, but it's got the oils in there as well, but it's also got other sterol compounds, catalysts and plant compounds. It's synergistic with natural components, and it forms one of the best all-round vitamin E's. But it's not always the best for all of them, because as we know, tocopherols are 4 different tocopherols. If we go back to the second module that we did, there's 4 different types of tocopherols and 4 different types of tocotrienols. So you have to muscle test really as to which is the best source of E. So sometimes the best source may be, the traditional one from soya or sunflower seed oils. Sometimes it might be another seed oil. It could be sea buckthorn in some cases. But the wheat germ seems to be a very good source of the gamma tocopherol, and not so high in the alpha and beta. So it's a matter of muscle testing which is the best source of vitamin E. Now, in your handouts here, you've got a sheet of the essential fatty acid synthesis. So we need to go through this. Looks very complicated, but in fact, once you get into it, it's relatively straightforward. So I'm going to just do a general overall picture of it first of all. So let's just go through the chart itself. So we have 2 essential fatty acids, which means that we have to get these from our diet. The body's unable to make these. So we've got linoleic acid here, which is an omega-6. You've all got this in your handout sheets? Yeah. Okay, linoleic acid here. This is the omega-6, 2 double bonds. And then we've got alpha-linolenic acid, which is an omega-3 oil here. Okay, so we've got a 6 here and a 3 here. From those 2 oils, we can make all the other unsaturated oils that the body uses by a matter of increasing the double bonds or stretching the number of chain of the carbons. So we can lengthen the carbons from 18 to 20 to 22, etc. And we can change an omega-2 2 double bonds into 3 double bonds into 4 and so on, providing we have the enzymes to do that. And the enzymes, as we know, convert a substrate to the end product. And all enzymes need coenzymes or cofactors to be able to get them to work. And at the same time, the enzyme is a mirroring or a product of the gene. So if the gene has a polymorphism in it, it may be that that gene can't work to the full expression. And so no matter how many cofactors and coenzymes you put, we still can't do that conversion. So we see a good example of that is the very first lengthening of both these fatty acids. So linoleic here is an oil, is a fatty acid which is rich in sunflower, olive, safflower, peanut, sesame, and macadamia nuts. Those are examples of nut oils. And these are the common oils that we get within culinary supermarket type oils. Now, with the enzyme delta-6 desaturase, we can increase this oil from being a carbon, having 2 double bonds to 3 double bonds. So in other words, we increase the desaturation, and that's called delta-6 desaturase. Now, delta-6 desaturase, to put the extra double bond in here, usually requires certain cofactors to do that, and one of those is zinc and magnesium, very important here to stimulate the enzyme. So gamma-linolenic, which is the 3 double bonds here, otherwise called GLA, is naturally the oil that's present in evening primrose oil, borage seed oil, and blackcurrant seed oil. Those are the main oils that naturally contain this stretched version or more double bonds of linoleic acid here. And this one with the delta-6 desaturase is an enzyme which doesn't always come up to fruition, to full expression, until about age 7. So these oils, these stretched oils, are ones which are very important in the skin, particularly with children who have eczema. And eczema will often respond to these stretched versions of the oils, even when the person has enough of the essential fatty acids in the diet, but they can't desaturate and elongate them into the required form for them. So a lot of eczema will respond to things like GLA because the delta-6 desaturase enzyme hasn't come up to full fruition, full expression, until they generally think about age 7. So very often children grow out of eczema at about age 7 because they're starting to make their own GLA then. Now if we go on the omega-3 side, we have a similar situation with alpha-linolenic acid, going on down here to the eicosapentaoic acid or EPA, and again by the delta-6 desaturase enzyme here, down to EPA, which has got 5 double bonds. So this elongation and desaturation again is done by enzymes, which are genetic expressions, and the same delta-6 desaturases may not come up to fruition or full expression until age 7. And this is why sometimes when people take enough omega-3, flax seeds, etc., they can't always convert it to enough EPA. So they have to take EPA in the way of fish oil, so they sort of jump-start this. And the same with DHA, which is derived from EPA. Now, clinical significance of these two oils here, these two fatty acids, is they go on to make anti-inflammatory prostaglandin series. So these are chemicals that the body produces which are anti-inflammatory. So they help to thin the blood, stop it from agglutinating, and decrease platelet aggregation. So the linoleic here goes on to make finally prostaglandins 1 series, which is anti-inflammatory. And the omega-3 here goes on to make prostaglandins 3 series. So this is why fatty acids can be anti-inflammatory. So people who've got chronic inflammation, like in joint problems, often omega-3 oils, sometimes omega-6 oils, can give a lot of relief for symptoms. So a lot of arthritic-y problems can be relieved by taking fish oils or GLA. And one of the most common ones of that is in the thumbs. So it tends to find you get arthritis in the thumbs. I occasionally get it myself with doing osteopathy, that you find you get pain in the thumbs there, and you think, oh, what have I done? You know, have I done too much neuromuscular work or whatever? And then I usually find it's that I need to take some essential fatty acids, usually fish oil, and then it disappears, and it's all, everything's okay. So what Dr. Goodhart found is that you get deposits of little grains of calcium, and now we know that may be due to the wrong type of vitamin D, but if you get a little grain of calcium into the joint in the synovial membrane, or into the bursa, or the tendon, the synovial or the tendon sheath there, it creates inflammation. And to get that calcium back into solution, you need the essential fatty acids. So this is why when people get pain, if they get relief from taking fish oils, etc., it's usually because they're removing the calcium, putting it back into solution, increasing the prostaglandins 1 or 3, which is anti-inflammatory. Now, going back to the omega-6 oils here, going back to the omega-3 here, we'll see that flax is probably 60%, maybe 66% alpha-linolenic acid, so it's a very rich source. Chia seeds is similar, around that sort of figure, so it's very high. Hemp is about a third, so that would be 33%. And black cumin seed oil also contains alpha-linolenic acid. Obviously EPA and DHA are rich by nature in fish oils and in algae. So going back to the omega-6 oils here, when we put the extra double bond on and make GLA, which is rich in evening primrose oil, blackcurrant seed oil and borage oil, we can then stretch it, elongate the enzyme here, to dihomo-gamma-linolenic acid, or DGLA. And DGLA is what's rich in breast milk. So this is a rich source of DGLA, which will then go on to produce prostaglandins 1 series, which is anti-inflammatory. On the other hand, DGLA can go over here with delta-5 desaturase and create arachidonic acid, which is a carbon-20 with omega-6 double bonds here. So arachidonic acid here is a very important acid because it forms the other lipid on the phospholipid structure in the brain. So lots of people think about arachidonic as a bad guy, but it's important, essential oil fatty acid for half the phospholipid structures in the brain. On the other hand, it can go on then to convert into prostaglandins 2 series, which is pro-inflammatory. So if we have too much arachidonic and we open up this pathway here, we may stimulate the production of prostaglandins 2 series, which can lead to pro-inflammation and clogging up of the arteries. Arachidonic comes from peanuts, red meats, and organ meats. So these are naturally rich sources of arachidonic. So we don't want to think about arachidonic as a bad guy because it's essential, but too much could set up a pro-inflammatory state. And this is why some people who've got pro-inflammatory conditions are better for cutting out red meat. Rheumatoid arthritis is a typical example of this. Taking a person off red meat, putting them onto white meats or even onto a vegetarian diet can decrease the inflammation, add fish oils to their diet, and we're doing 2 or 3 things to reduce the inflammatory response. These were old naturopathic terms, 30, 40 years ago, but they're as good then as they are today. Okay, so arachidonic tends to stimulate the pro-inflammatory prostaglandins 2. So prostaglandins 1 and 3 are anti-inflammatory, prostaglandins 2 is pro-inflammatory. So we'll look at these pro-inflammatory, anti-inflammatory prostaglandins in detail a bit later on. Now both the enzymes, which are called prostacyclins, which do this, cyclooxygenase COX enzymes, cyclooxygenase enzymes, tend to convert the oils, the fatty acids, into the prostaglandins in all 3. So cyclooxygenase enzyme converts all 3. So if you block cyclooxygenase, which is what a lot of anti-inflammatory drugs do, is you stop the production of prostaglandins 2. Okay? So you get instant relief from your pain. But you also block 1 and 3, which are anti-inflammatory. Okay? So in other words, you're blocking the healing. So we need inflammation in some ways to lead to the resolution of pain. So sometimes we need inflammation in the first few days after tissue injury. So if you start blocking it, you then don't heal. Okay? So you get instant sort of relief or the quick fix, but at what cost? Because you don't then get the inflammatory process. So you don't always want to block cyclooxygenase. It's better to do it naturally and to stimulate the anti-inflammatory ones with the right oils in the diet and decrease the red meat, etc., to stimulate the prostaglandins to inhibit the production of prostaglandins 2 series. So that's basically the chart in a nutshell. So let's have a look at various bits in more detail. So GLA, as we said, is rich in blackcurrant seed oil, evening primrose oil, borage oil. Polyunsaturated oils in the brain, which, as we said, are arachidonic acid, which is AA, and DHA. DHA is primarily in the cerebral cortex. That's the frontal part there, used for working memory and short-term memory. AA is primarily in the hippocampus and is used to consolidation of short-term memory to long-term memory and spatial navigation. The DHA is the most abundant omega-3 oil in the brain generally, 40% in the brain, 50% in weight of the neuromembranes. It's synthesized from alpha-linolenic acid, rich in fish, egg yolks, and breast milk. It's structurally comprised of 22 carbons, so it's very long, but the important thing here is it's got 6 double bonds, so potentially it can become very oxidized very easily. It increases the fluidity because it's very low melting point. DHA has a melting point of minus 15 degrees. So it will not quite freeze in the freezer, which is usually about minus 17. About minus 15 is enough to keep any fish nice and flexible in the bottom of the North Sea. Whereas EPA is about minus 13, so it's not quite as flexible. So the more of these oils that you have, the more flexible we become. And you can demonstrate this with people who are stiff, and if you put them on, say, omega-3 fish oil supplements for a while, they become more flexible and they have greater range of movement. So alpha-linolenic acid, or what's rich in flax oil here, goes to EPA, goes to DPA and DHA. So we're stretching from 18 to 20 to 22 to 22 carbons here, but we're also increasing the double bonds from 3 to 5, 5 to 6. So DHA is the most highly desaturated oil that you use, and therefore the highly prone to oxidation. So again, we're seeing that one. So the more double bonds you've got, the more curving round you have. As we mentioned, like more of the matchstick is broken. So here we have DHA being almost forming a circle in its structure there, as opposed to alpha-linolenic with 3 double bonds. Now the conversion of EPA enzymes in the conversion, desaturated, addition of double bonds. So anything that desaturates and adds is called a desaturating enzyme. So it could be delta 5, delta 4, delta 3, delta 6, delta 5, and delta 4. And elongation enzymes or elongase enzymes just literally put another 2 carbons on. Remember, to build carbons up, it's always in 2s, never 1s, or shouldn't be 1s. Genetic variability in enzymes involved in fatty acid metabolism influence the ability to generate these long-chain fatty acids. Polymorphism in the genes, and look for the coenzymes needed for the mineral cofactors. So each of the enzymes has cofactors and coenzymes. In other words, coenzymes are vitamin Bs, like pyridoxal 5-phosphate. Cofactors are going to be zinc and magnesium, the usual friends there. But the important thing is, does the enzyme express itself enough? Does a dry child, if you like, with the skin and eczema, often have a mother or a father who's got the same problem? So if that is the case, if the mother or father is still alive, has the dry skin, then they probably handed on that gene, and that gene is encoding for the ability to activate the elongation or desaturation of the oils. So it's expression of the gene. How much does that gene express itself? Can we get that gene to express it better by giving the cofactors and the coenzymes? Or should we just supplement in with the end product, the EPA or DHA? So top fish sources of DHA, tuna, mackerel. Tuna is debatable because it's not a fatty fish, but it does contain a lot of DHA. Mackerel, so that's a good fatty fish. Swordfish, salmon. Salmon is mainly when it's in the ocean rather than in the rivers. So when it's in the river, it's not got so much of the good oils because it's warmer water. Anchovies are generally better because they're smaller fish, so they don't contain the toxins so much. Herring, sardines, and anchovies, together. And caviar. So cooked salmon is 500 to 1500 milligrams. Recommended daily intake, maybe 650 milligrams of DHA. The other week I was with a group, and this man who was about 70-something suddenly had a heart problem, a heart issue. He was taken to intensive care, a chiropractor. And they couldn't work out what it was that was wrong with him, so they did all the screening and everything. And he got a collapsed valve in there because of a damage to one of the little cords that holds the valve up. And they said, it's amazing, you're 70-something, you haven't got any arteriosclerosis at all. Arteries are absolutely crystal clean. You're the last person to get a heart problem there. And he took 3,000 milligrams or 3 grams of fish oil every day. And so that kept his arteries clean. So 3,000 milligrams is roughly 3 capsules. Commercially, most capsules are 1,000 milligrams or 1 gram. So a good idea to perhaps to incorporate in, and we saw yesterday maybe fish oil is important also to keep our GGT down. So maybe taking a good fish oil supplement, a good clean one, at the rate of about 3 grams a day is a good idea. And in fact, that's what we tend to find clinically, is most people measure if they need fish oil, EPA, DHA, it's about 3 capsules, which would give us probably the equivalent of a few, 1 or 2 herrings every day. So algae is the other source for vegetarians here, or people who just need DHA. And egg yolk, as I said, is usually particularly when they feed the chickens flax seeds to eat, and the chicken is able to elongate and desaturate alpha-linolenic into DHA. So a lot of research has gone into this, that low levels of DHA, which are particularly the fatty acid incorporated into phosphatidylserine, is associated with cognitive decline. It's likely to develop dementia and other cognitive disorders. So looking certainly people with cognitive disorder, whether they're Alzheimer's or not, or vascular dementia, whatever it is. Obviously, essential fatty acids are important, and they may not show necessarily to fish oil as an omega-3 source, but it may be just the DHA component that the person needs. DHA accumulates, as we said, in phosphatidylserine. Phosphatidylserine controls the apoptosis, and low DH levels lower neuronal cell phosphatidylserine and increases neuronal cell death, particularly in the hippocampus, which is associated with memory recall. Hippocampus is severely affected, we know, in Alzheimer's disorders. DHA supplement improves memory in Alzheimer's and old age. So we know in Alzheimer's, just as a specific problem, if it is really Alzheimer's, there's usually an inflammatory process as well, which is why you have this interest in anti-inflammatory agents like turmeric. And as we know, you need to get turmeric into the body in sufficient amounts. You have to have piperine or something like frankincense, boswellia, or black cumin seed to be able to absorb the active ingredients in turmeric to reduce the inflammation in the brain. But those active ingredients have got to get across the blood-brain barrier as well in order to stop the neuronal death there. So maybe spices like that, and maybe as we find that cloves may be better than turmeric ultimately for their anti-inflammatory properties, for the mechanism that we've described, and along with DHA or EPA DHA supplements. So now you've got a few things that you can think about to protect yourselves and patients who've got memory. Because memory problems, remember, were the third biggest cause that people go to see the doctor or healthcare practitioners. Tiredness, pain, and memory are the first main three there. So studies in mice and primates show that DHA-depleted diets impair learning as well. So again, important with children who are in a learning situation. So children right from the beginning should have extra oils if they got dry skin. So the body being holographic, if you've got dry skin, you're dry inside. Okay, so this is why we chose somebody who got a little bit of dry skin, because if you've got dry skin here, you've probably got dryness inside. Okay, so the skin is really a reflection of the ectodermal tissue in the body, which is the same as the neuronal. So when you look at the skin, you're really looking at the brain at the same time. So dry skin, dry brain. So remember that. Refeeding DHA diets reverses these impairments in learning. Chicago and Rotterdam studies found 60% reduction in Alzheimer's incident when taking omega-3 oils. Also found that intake of plant-derived omega-3 oils, alpha-linolenic, was associated with reduction in the risk of Alzheimer's disease in subjects with ApoE4. We're going to discuss ApoE4 a little later on today. This is an enzyme, ApoE, which carries fragments of cholesterol away from tissue oxidized cell membranes in the body, but it also carries toxic metals away. And it doesn't do it very effectively in ApoE4, whereas ApoE2 and 3 are better detoxifiers. So ApoE4 is an allele, or a expression of the ApoE enzyme, which is like the short straw. It has 2 arginine molecules there instead of 2 cysteine molecules. And as I taught you yesterday, that cysteine has sulfur, which has valency of 2, 4, or 6. So if you've got cysteine in the molecule, it can act to detoxify. If you don't have cysteine, and those cysteine molecules are replaced by arginine, it doesn't have the ability to detoxify. So if you're blessed with ApoE4, you're going to have a tendency to build up oxidized cholesterol fragments in the body and toxic metals. So this, they know, predisposes people to certain illnesses. So if you've got the ApoE4 expression, and let's say you couple that with high GGT and low oils, low omega-3 oils, and then you've got a sort of recipe for getting a lot of different disorders, particularly dementia. So ApoE4 is a powerful indicator of Alzheimer's. It's not a universal, the beta amyloid protein fragment is the best marker that we have. But most Alzheimer's cases have got high ApoE4. But if you've got high ApoE4, it doesn't mean you're going to get Alzheimer's. Okay, so don't worry about it. But the more you can do to help adapt to that defect and help detoxify heavy metals and oxidized cholesterols, the better. So the conversion of various fatty acids to DHA may not be effective, as we said, particularly the delta-6 desaturase drives up at about age 7. The linolenic acid is desaturated and elongated. Estimated that you need 10 to 40 grams of flaxseed oil to produce 200 milligrams of DHA. if you haven't got a good working delta-6 desaturase. So that's a lot. So some people just really can't convert enough. So a poor expression of the delta-6 desaturase enzymes really does mean that people can't make EPA, DHA very effectively and have to take it in the form of fish oil now. So marine algae is relatively expensive in comparison to obviously fish oil. So deficiency in DHA can be caused by problems by people not being able to convert EPA into DHA sufficiently. So it's essential for healthy structure of the brain, essential for the adult brain, promotes nervous system development and helps prevent dementia. Arachidonic acid, as we said, is an omega-6. Neurological health is dependent on sufficient quantities. So this is the one that forms half the phospholipid structure in the brain. It maintains the hippocampal cell membranes, protects the brain from oxidative stress. It's rich in most meats, eggs and dairy. It's involved in early neurological development. In adults, the disturbed metabolism, particularly if it goes on to drive into the pro-inflammatory prostaglandins 2, can lead to Alzheimer's and dementia. So if we just home in a little bit on around here, we'll see arachidonic acid. And here we've got our cyclooxygenase enzyme, same one as here and here. So this is converting arachidonic acid into prostaglandins 2 series. And prostaglandins 2 series is pro-inflammatory, whereas if you remember prostaglandins 1 and 3 is anti-inflammatory. So the same factors stimulate it, and the same factors inhibit it in all 3 cyclooxygenase pathways. And the common denominator here is that they tend to be inhibited by non-steroid anti-inflammatories and aspirin. And this is the mechanism that ibuprofen and aspirin work by blocking prostaglandins 2, but at the expense of blocking prostaglandins 1 and 3. Now there's another enzyme here called lipoxygenase, which can convert arachidonic acid into leukotrienes. And leukotrienes are 1,000 times more inflammatory than even histamine. So these are the worst forms of inflammation, the highest forms of inflammation. And the thing that stimulates this is the non-steroid anti-inflammatories. So this is the story that people take non-steroid anti-inflammatories and they feel better for a while, and then their pains come back and worse. So they take higher and higher doses of the non-steroid anti-inflammatories, and it's driving, what it does is it inhibits this enzyme and it drives it into this one. So as a result of this one, we get a greater amount of inflammation. And these people then end up having to go into hospital and taking off all medication because they're reacting and they're in so much pain. So it's the short-term benefit, the fix, if you like, of non-steroid anti-inflammatories, but the long-term can be even more destructive. And a good example of that, of course, is the stomach, isn't it? That it tears the stomach to bits and they can perforate and all sorts of things. But this is when people get extreme amounts of pain. And the two things that I find drive that process into leukotriene B4 especially is allergy, something that the person is eating. And very often with what the person is eating is our old friends isothiocyanates from cruciferous vegetables. Nothing seems to drive this faster than taking a good dose of cyanide. Okay, so isothiocyanates are cyanide. So that's very good against cancers and things like that in small doses. But if you can't metabolize the cyanide and get it out, you build the cyanide up and it stimulates the production of the lipoxygenase enzyme and inhibits the COX cyclooxygenase enzyme, the COX enzyme here. So it drives it into a pro-inflammatory condition. So very often, if someone's got a lot of pain, check all their food through. Okay, 50% of what a person's problem is, Jonathan Wright always said this, 50% of the symptoms of a person is what they eat. Okay? So do a test on everything that the person eats, and most of the time you'll find it's something which drives that inflammatory cascade, and cruciferous vegetables are the main one. Probably followed by the deadly nightshade foods, the solanines, the potatoes, the pepper and the tomatoes and things, but nothing more than broccoli, kale, spinach, etc. Those dark green leafy vegetables. It's not an allergy, they've just got to come off them for a little bit or reduce them down severely so the body can get it down to an optimal level again. So 50% of leukotriene formation, if you like, is from foods that we eat. And the other one you always want to look for is parasites. Parasites produce huge inflammatory reactions, very often nowhere near where they are, which means they're producing chemicals that are getting into the system and producing inflammation systemically. So the patient may have swelling of the knees, swelling of the feet, problems with the kidneys, so they get edema in the legs, extreme pains, tiredness and all the other symptoms. And then you discover that the main meridian is the large intestine, and then that feeds you back into thinking, this could be a parasite. So parasites are devious little devils, and they produce byproducts. And those byproducts are ammonia and phenol. And some produce toluene and other solvents. But it's the phenol and the ammonia which get into the blood and go round us and are so toxic to the kidneys and other joints. And remember, parasites, of course, can also be systemic. Just, the main big boys, if you like, of the helminths may be located in the gut. But sometimes they can get into the rest of the body. Trichinella, for instance, gets in, pigworm trichinella can get into the muscles and make its way around the muscles, and you can imagine there is. As come horrifically tapeworms. So cestos can also be systemic in areas like the brain and down in the muscle tissue. And again, nematodes, small worms. There was even a picture of somebody on television the other day with it coming out the eye. So, you can have worms inside the body, not just in the intestine. And of course, nobody thinks of the possibility that you could have a parasite actually inside the body systemically going around. So they can produce enormous inflammatory reactions. And nobody would think about, this could be a parasite. So we need ways of measuring this. So if a person shows positive to leukotrienes as a chemical that drives the inflammatory process, think then what could cause leukotrienes. Don't just think, increase the fish oil. Think what could stimulate leukotrienes, and it'll be either something the person's eating or a parasite. Okay, so foods high in arachidonic acid that could do that would be the red meats, organ meats, etc. Pork may be in there, oils such as peanut oil, particularly not very good ones, and egg yolks. So generally they're good foods, but too much of anything can be excessive, particularly in certain circumstances. So linolenic from sunflower seeds, etc., goes to GLA, goes to dihomo-gamma-linolenic acid and arachidonic acid. So test for defects in arachidonic acid synthesis by looking at the two enzymes there. Dietary factors that can stimulate it would be trans fats, high saturated fats, too much glucose and too much alcohol. So if we look here at the omega-3 cascade, let's go back to arachidonic acid, key inflammatory intermediate. Arachidonic acid metabolizes to both pro-inflammatory and the anti-inflammatories. It keeps the inflammation process as a balance or under control there. It removes the building block of excess, reduces intake of bad omega-6 trans fats and hydrogenated fats. So here we see the first introduction of hydrogenated fats, which are oils that have hydrogen pumped into them to make them harder. This is in the margarine, in the vegetable margarine industry. So there are 3 compounds which are very good at helping to get rid of these bad metabolites. And this is ginger, onion, and garlic. We'll see this comes up in many of the fatty acid cascades. Ginger, onion, and garlic. Otherwise, we call it GOG into the diet. So fats, we've mentioned about how to prevent memory. So looked on again this chart, linoleic acid, alpha-linolenic, going down to EPA, prostaglandins 3. Linoleic acid, GLA, gamma-linolenic, prostaglandins 2. and dihomogamma-linolenic acid go into arachidonic, which can go down to prostaglandins 2, which is pro-inflammatory, leukotrienes, which we briefly mentioned, thromboxins and prostacyclins that we'll see now. So key nutrients for synthesizing the different phospholipids we talked about. This is the omega-3 pathway, again from alpha-linolenic going down to DHA here.